All right. You can all hear me. Okay. Okay. I am not truly the barley breeder at UNL. I am the small grains breeder. And so my responsibility is wheat, barley, and triticale. But as you'll see later in this presentation, the responsibility for the barley program really goes to others in my program. And so what I've got here today, and is that changing online? Okay. Is a little bit about our barley breeding program, and how it operates, how we're evaluating progress, and then really the important part of this program is what this program contributes to training the next generation of plant breeders. So I did not know this until we put this together for a department seminar last semester, but the Nebraska barley breeding program is actually nearly as old as our wheat breeding program, which is the major program in Nebraska. And so the current forms of the wheat and barley program were really initiated sometime in the 1920s. There's documentation of some wheat and barley breeding being done by some agronomists prior to that date, but the breeding programs have really been around since the 1920s. Many of those early barley releases were spring barley, but the program has been a source of winter and facultative barley. Our current form of the wheat program really, with kind of some joint UNL and USDA research, has operated since the 50s. And barley was actually a separate program, even in Nebraska, where we've had relatively low barley production, even at that time. It was a separate program until a merger in sometime in the mid-60s, is what we've been able to track back by looking at PhD theses in our records. So I will, out of all of the speakers today, who I think most of my messages have kind of already been covered by some of our fabulous speakers already. But I'd say so far, I'm definitely the one to stand up here and talk today with the least amount of acres. We have very limited feed barley production in Nebraska. We have probably negligible malt production, just people who want to have some fun and try and grow some malt barley. But if you remember back to the presentation earlier today, Nebraska is kind of it for barley breeding in the southern Great Plains. We're kind of the last ones standing. So it has been kind of emerging back into growers' notice. And it's also been an opportunity for producers to diversify. Maybe they want something a little bit earlier than wheat production. They want some alternative systems, cropping rotations, and wheat is just too long of a growth cycle for them. So Nebraska, Kansas, Oklahoma, even into Colorado, I get some phone calls from growers in Colorado every once in a while looking for winter barley that they can use in their rotation systems. To that end, I also get a lot of phone calls about malt and forage type barley. And so we are working on that in our breeding program. I feel like I a little bit run a referral program for barley producers in the Great Plains. So they ask me questions and I say, I don't know, but I'm going to refer you to this grower who called me last month in Kansas, and you guys should talk. So I do a lot of that. But our breeding program is a chance to make connections for people. And our goals are still just like all of the other programs. We want to improve yield, winter hardiness, disease resistance, and then help people who want to start a niche industry, or they want some novel food or beverage production, and we're here to help with that. So our historical focus is 6-row feed barley with awns, but our breeding program now includes all of these 2-row malting types, And like Bob said, malt-ish. I don't know that there's anything in our program that is really truly that close to malt barley. Um, I have a big demand for forage now, so we're putting a very big emphasis on onless and hooded barleys. We've had quite a few releases, primarily throughout the history of the program. They have been public releases. We went through a period in the late 90s through early 2010s where all of our barley varieties were licensed to a company in Kansas. That company went out of business. And so now we're back to doing public releases, and New Horizon Genetics is marketing those. So this is what makes our program special, is that it has been led by PhD students for over 50 years now. We have a list of 20 plus student barley breeders. It's actually maybe close to 30 different student barley breeders. And so the students are responsible for the program. I just get to say yes or no, that's a terrible idea. I very rarely have to say that's a terrible idea. I more often have to say, well, let's think about the consequences. So students really get hands-on training. They have to work with the technicians in my program to get everything planted, the data collected, how they wanted, and they make the advancement decisions. And so our barley program is going to look pretty similar to a lot of the other programs we've seen today. We have traditionally been a F3 derived program with our F1 increases occurring down in Yuma, Arizona. I'm really jealous of those who get to go somewhere fun for winter nursery. We just go to Yuma, and depending on which field we're in, we do get sometimes a notification of welcome to Mexico if you walk to the end of the field. So that's about all we get for winter nursery. We have adapted the program. We made this change primarily for the wheat program, but it's just easier to manage all of our programs the same. So we've switched to an F4 derived program. And then we're pretty much operating like all of the other programs we've seen so far today. And primarily our crossing material is either going to be coming from lines entered in our advanced yield trial or out of some of the collaborative nurseries that we participate in. So one challenge of running a student-driven program is that the breeders turn over very frequently. So we're talking a new breeder every 2 to 3 years. And they have varying levels of interest in the barley program. Some of them are much more passionate about their major research project. And we had never actually stopped to evaluate how that program was doing with turnover every 2 to 3 years. So I had a PhD student, now Dr. Sydney Graham, who wanted to do a statistics master's simultaneous, and she needed a separate project for her statistics master's degree. And I said, well, let's use the Barley program, because she was running the Barley program at that time. So this is what she set up. She wanted to look at genetic gain and then actually initiate a genomic selection program to try and put a better framework for future breeders in place. So I'm going to go through a lot of this really quick. What we did is we pulled together 302 unique lines that were evaluated in our advanced yield trial for a 20-year period. We had several sets of checks. The only one that was available through that entire period was P954. We grow our barley trials at 3 locations in Nebraska, 2 in eastern Nebraska, so high rainfall areas, and then 1 out in the Nebraska Panhandle, where it's a higher elevation, semi-arid, cold, dry environment. And so one of the most fascinating things that Sydney found is that we didn't turn lines over very quickly. On average, 58% of the lines from any one of these years were also evaluated in the previous year. And if we're running a breeding program, that's probably not okay. That's actually hanging on to lines much longer than my wheat program. And I think this would be P954. Oh, you can't see my mouse on here anyways. So that line on your left there, that's probably P954. Ignore the colors. Basically, what this means is the longer a single line has a vertical bar, the longer it stayed in the trial. So this is probably related to the students being kind of unsure of what to do when they take over the program. And well, I'm sure Sydney had that line in there for a reason. I probably shouldn't throw it away. And so we were really hanging on to about 60% of the lines each year in our advanced yield trials, whereas with my wheat program, it's probably more like 30%. So then looking at this data set, we calculated genetic gain. I didn't put the equation up there because I kind of assumed that you all would have seen the genetic gain equation, and we have seen it several times already today. So we looked at this, and hey, it is not flat. There's a slight positive incline there, guys. So we're doing, we are making yield improvements. It's pretty slow, and a lot of that is probably because we're hanging on to lines for a long period of time. And the longer we hang on to lines, the less turnover in our parents we have. So that's definitely one of the things that Sydney highlighted is we probably need to move things a little bit faster. This is just her summary of what 20 years of yield data look like. We chose yield. That's the thing we have the most consistent data on. Pretty typical. Lincoln and Meade is usually going to be our higher yielding environments. Sydney, much higher stress environment, tends to be our lowest performing. Then we also really wanted to look at winter survival because we do test lines for other breeders. We generate a fair bit of winter survival data, but it turns out in our own program, we have not been very good at actually recording it. Again, with our students, we think we have more data than this. We do have a lot of years where either everything died or everything survived, which is why we did not include those, but also we have a lot of missing data. And what we think happened is it didn't end up in our database. Our students maybe collected the data, it just didn't get recorded. And as breeders are transitioning every couple of years, it's much easier to lose track of data. So we have winter survival, but it's really not the data set we were expecting. We have just recently started using genotypic data in the breeding program. We utilize the 3K SNP chip out of the Fargo lab because we can genotype both our wheat and barley lines on that. We were able, over that 20-year period, we were able to find 189 of the 302 lines, which is not too bad, considering that we're not as consistent at getting the barley lines into cold storage as we are with our wheat program. And then Sydney had a testing set, which was the 2024 preliminary yield trial. She also wanted to look at whether environmental data could help with these predictions, especially because we're working with winter barley. Because this is a statistics master's project, she has a whole suite of genomic prediction models that she wanted to use here. Our baseline was a GBLUP, which is functionally that RR-BLUP model that we saw earlier, and used either genotype or an environmental, our standard just location covariate, or she utilized weather data as well with that GBLUP model, and then the Bayesian alphabet and several machine learning models. Looked at a couple different training sets, looking at what we would really prefer to use, which is just the, maybe a few years of most recent data. So that's that scenario B, 2020 through 2022. And then since we have a lot of the same lines, she actually looked at using all 20 years of data in our training set. And then here's her testing set, and where I really want to, yeah, actually you can see it, okay. you can see kind of this is our, nope, you can't see. In our PCA, as you are moved, there's that little outlier set in our testing population. That's kind of where more of that malt barley germplasm is coming in. We don't have a lot of that in our older lines, and so that's kind of why we see that cloud of points extruding from the main body of the prediction. And this is looking at her weather data, and I'm going to walk over and point out because that little piece that ring bill, that is the environmental or the weather data for the year of Sydney's testing environment. So we had a very typical Lincoln environment that she was trying to predict, which made this a little bit easier. I guess I had an arrow there to help. So because this screen you can't really see very well, I'm going to go through this pretty quickly, but it comes out that almost always when we have 20 years of data, it works better because we have so much overlap between those years. So 20 year, we maybe wouldn't see this in most other breeding programs because we have too much turnover from year to year. But for us, 20 years of data is going to work better. Bayes A was the best model, and our machine learning models did not work well. And guess what? Isn't that exactly what we heard earlier? We still, even though Sydney found Bayes A was the best model, we still tend to use GBLEP models because they're computationally easier and quicker, and it was not significantly different than that Bayes A model. We did look at trying to predict winter survival, and this is the only place where actually using weather data really helped us. Probably not surprising, but again, these are really low prediction accuracies, and that just goes back to we didn't have that much data recorded. It really only works, though, when we try to predict within one location. When we focus on just our Lincoln data, could predict better. If we tried to predict both with Lincoln and Meade data, our prediction accuracy absolutely bottomed out. This is probably not surprising because despite those two locations being only about 45 minutes apart, our Lincoln site is actually within the city of Lincoln, and Meade is a colder location out with very little wind block to protect some of that barley. So this is what Sydney came up with as kind of the summary of her statistics work. Genomic selection is going to work for us. It's probably a good way to help the new breeder feel some confidence because they can utilize the genomic prediction model started by the previous breeder, and it provides a guideline for selection. We do have to figure out how long we want to keep using that 20-year set. If we start turning over lines, we may finally get to that point where we want to use more recent data only. Number one suggestion was reduce that year-to-year overlap to better match the wheat program. We do not need to be saving nearly 60% of the lines every year. We do need to make sure that winter survival data gets collected and actually recorded in our long-term database. It doesn't matter if it was recorded and the student has that data, it's got to be in the database. And so we are going to really expand on the yield genomic prediction work and primarily adding into winter survival and fusarium head blight work. So for me, as the supervisor of the small grains breeding program and the one who is getting those phone calls from stakeholders, what do I really need to see? What are the messages that I need to give Raphael, our current breeder, who is here today? And I hope you all will get a chance to chat with him and give him advice. To be honest, yield is not a concern for us right now. We do need to continue making progress, but the biggest thing we need is adaptation. Adaptation for winter production in Nebraska, Kansas, Oklahoma, Colorado. Because the number one questions I get is, do you have an X variety from Nebraska that I can plant? And the answer is, yeah, not really, unless you're looking for a 6-row feed type. The next question is then, is this line that I found I can get from a European breeding program going to survive in Oklahoma or Kansas? And I say, I don't know, but call this farmer. They've tried some things. Will spring barley have malt quality in Nebraska? And I say, probably not, because it gets too hot and it's going to fry in the summer heat. And then P919 is our winter on-list forage barley. And people ask, like, do you have something with a little bit better winter hardiness than that line? So for us, it's really a chicken and egg issue in the region. We have a lot of opportunities. We've got dog food plants in central Nebraska that use a ton of barley. There are some people who would like to do some niche malting or local craft breweries that would like to have locally produced malt. We even have had ardent mills asking about barley for some pearl barley products. But without a steady supply, the end users can't really commit. And without a steady end user, the growers can't really commit. So I think one thing for us is really supporting the use of barley as an alternative crop and crop rotations. Potentially policy changes could really help growers who are interested in a cover crop or a double crop situation. And that would help us increase some of those barley acres and then get to that point where we have a steady production. So that way we can build more of an industry around it. And so that's kind of where we are with our how do we best serve stakeholders and how do we make sure that we remain the last barley footprint in the Great Plains. And I'll wrap up by saying that the one thing that really helps us is that we are operating this program, with the support of U.S. Wheat and Barley Scab Initiative, AMBA, and the Nebraska Wheat Board, and most of the student stipends, those GRAs that are running the program are coming from other projects. So we're running this relatively cheaply, and it means we can't afford to keep that foothold. But it all comes back to we do need to train the next generation. And so some of you who are plant breeders and faculty may be familiar with these studies. These are now almost 15 years old. And these are 2 publications that we're looking at what do stakeholders want in new plant breeding PhD graduates from private sector, and then a look at both private and public stakeholders worldwide. That private sector stakeholder, I think, was just US. So the top ranked skills, and I apologize, this is really hard for you to read. Top ranked skills from one paper was design experiments, design and analyze field-based experiments, use the scientific method to analyze data from field trials, initiative, design and set up experiments. These just kept coming up. Critical thinking, discern meaning from data, really important skills for graduates. And then from the second publication, they grouped these a little bit differently, but in the center of their Venn diagram was skills that everyone, public, private, worldwide, agreed on, is that they wanted field work, interpersonal, practical breeding, statistics, research skills, experimental design, scientific communication. These are all things that industry valued. And so our goal is to eventually turn this into a publication about the education side of the barley breeding program. But we're starting by just surveying some of our former graduates. And so we reached out to the 5 most recent barley breeder graduates. Got responses from 4 of them. One of them declined to share their current position. But most of our students are staying in to the plant breeding industry. All of them are either running or working in a plant breeding program, and they all got jobs very quickly. And so this was kind of just what they highlighted as skills that they gained when they were running the UNL Barley program. Data analysis, experimental design, and this is number of students that mentioned these skills. Basic plant breeding and genetics, hands-on breeding, record keeping, program management, problem solving. We do a lot of problem solving in this program. Decision making, leadership, stakeholder communication. And so these are really matching up with those stakeholder surveys in the literature. We asked them, how confident were you on these skills before you started running the Barley program? Because we do usually have PhD students, and so they're coming in usually with a master's level experience. And then how confident are you after you leave the program? So you can see that in the black, this is their confidence in making breeding decisions before they started running the breeding program, and in red after they like right at graduation. How confident were you? And so we had one student who came in quite confident with breeding decisions, but still managed to really increase their confidence. We had several students that had very low confidence in their ability to make decisions in a breeding program, and they ended at with a significant improvement. And then this one is, how helpful was running the Barley program to actually understanding what a full breeding pipeline looks like. Most students, when they're doing research, they're looking in just one area of the pipeline, or they're not really working in the program at all. So students in this program are running the whole dang thing. And then just wanted to share some comments. We asked them, compared to your peers that had got a PhD from another plant breeding program, do you feel your experience gave you an advantage when entering the job market? Expanded my network, and this is what made me feel really good. I was able to position myself as an applied breeder with experience rather than as a student who helps out when others tell me what to do. The experience leading the Barley program gave me and the hiring committee confidence that I could independently run a program from day one. And that I thought was really, really cool. And would you recommend to other programs and universities to adopt a student-led breeding model? Why or why not? And they all said, yeah. But, keep in mind this challenges of frequent turnover, so it probably does need to be a program that you don't need a release every year on. And then kind of looking at their recommendations for what we should do is they do want more contact with stakeholders, so that's something we need to do better on. It is still me primarily doing those interactions. Add more of the malting data into the program. Participate in field days and meetings. Our field days are very wheat focused, but we could add barley into those. And then they asked for more testing locations and more crosses. So that one's gonna have to be a little more of a negotiation, but I do see the value of that. And so that's where I want to wrap up. Want to acknowledge Rika Howard, our statistician, who worked with that, and then all of our previous barley breeders, as well as our funders who keep this program rolling.
Thanks, Katherine. We'd have time for one or two questions.
Thank you. Katherine?
Yeah.
So, Tyler Shan, USDA. So, my question is about the machine learning part.
Yes.
I'm glad that Bayesian methods work. I wasn't surprised that support vector machine did not work because they are usually good with binary problems, but not like these types of problems. But maybe deep learning methods or newer decision tree methods may work better. But you alluded that the training data may be limited. So do you think, going back to Nick's presentation earlier, do you think that helping the nurseries will create more training data perhaps for better, more precise predictions?
Yeah, I do think the limitation in this is that even though we've got 20 years of data, it's functionally on not very many lines. And so that is, I mean, it was already mentioned today that barley is a relatively narrow genetic base anyways. It very much is compared to my wheat program. So add that narrow genetic base to the fact that we weren't turning over lines very often. And yeah, we have a very small training population. And I think increasing that, having more data on more lines is absolutely going to improve that.
All right. Thank you, Katherine. Okay, next up before our break, we have Kevin Smith, barley breeder at the University of Minnesota. Kevin has long managed the winter malting barley trial, and today he'll share with us a reflection on that work and the future.
Yeah.